I'm Paul Witheridge. I look after the work and rescue side of Line Equipment Limited, and we've been asked to provide some testing of these stretchers to see how robust they are and how potentially robust they could be in service. The two tests we're going to do today, one is a dynamic test. We want to be certain that the handles and fixtures and fittings of the stretcher will survive repeated, fairly heavy frequency bouncing, as if somebody was being carried at speed across rough terrain perhaps. We also want to check that the casualty, in our case a dummy, isn't going to actually physically come out of the stretcher at any stage. The second test that we will do is a static load test. We're going to test it to way beyond what the manufacturer actually states is the maximum load. We would like to get to a point where we can see there is a good factor of safety on all of those joints. The dynamic tests, which really replicate what would happen with a more heavy-duty metal type stretcher, but we want to try and see whether the performance that this stretcher can give is equal to that. We place a 100 kilo dummy into the stretcher. The dummy is a human form, so it will pressurise the stretcher in various places appropriately for its intended use. We then use a multi-point bridle to join all the handles together so that we can spread the load. The stretcher itself will then be attached to a dynamic rope of a particular standard, similar to its used for other stretcher testing and for harness testing the world over. So by doing this, we're again trying to run parallel with much more heavy duty stretchers, but give a benchmark to see whether this stretcher performs as well as your regular stretcher would in these service conditions. What we'd like to see from the test is obviously the stretcher to remain fully integral, all the handles to remain undamaged, all the seaming to remain undamaged, and most importantly the casualty not to be released from the stretcher. The second test that we're going to do is a static load test, again to check the integrity of the stretcher. A special frame that we place above the stretcher and then support all the handles equally yet again. We'll be placing 25 kilo weights to start with onto a wooden body form that's placed in the base of the stretcher. Once we've got all the 25 kilo weights on, to make sure we can compact as many weights as possible into the test, we drop to a 20 kilo weight. We will keep adding weights in a set pattern using a delay interval between each mass being applied and checking for any signs of damage as we go through the test. Ultimately, we'll end up with just over 1,000 kilograms in the stretcher. The stretcher that you can see in the background behind us, that's got 1,010 kilos on that, and throughout the little session that we've just done, you've seen it's held the mass without any problems at all. There are no signs of damage to the stitching or any of the seams. All the material internally, the lining material as well, when we take the mass out, will be intact.